Hello everyone, welcome to another video from Advanced Math Tutors. Today, I wanted to bring you something that always confused me as a kid, and that is numbers in different bases. Now, you and me, we live in a base 10 system, and that means we have 10 symbols to represent our numbers, and we're familiar with these symbols. That's these guys here: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And there's no number in our system that doesn't use one of these, or there's no number that has a different symbol than one of these 10 symbols. And so what we do when we want to list out all the numbers, this is how we create numbers. Let's start at 0, and we'll go down until we hit 9. But look, we've run out of symbols that we use. And so what do? Well, you and I both know the answer to this. We're kind of taught this in our uh, primary school math classes. We just add a 1 to another column, and we restart at 0, right? This is the number 10. And we keep going until we get to the number 19. And we know what to do now. If we want to create the next number, we just add 1 to the second column and restart at 0. And we do this all the way down until we run out of symbols for both columns. So in our case, this would be the number 99 in base 10. And what happens now? Well, we know we just add a third column and restart both of the other columns back at 0. And we can continue this pattern onward. And this is base 10. This is how we create numbers in base 10. So what you can think about is this column here is the ones column, this column here is the tens column, and then this column here is the hundreds column. And if we were to continue down, we would get the thousands column, and then the 10,000s column, and so on. And so what we can think about, let's say I have the number 121 in base 10. This is equal to, this is 1, 1, so that's just 1. 2 tens, that's 20, so 2, 0. And then 1 100, which is 100. And we can think about this number as just adding up all of these values, which to us would be 121, unsurprisingly. But what if I had a number in a different base? What if we didn't use base 10? What if instead we used something like this, base 5, where instead of having 10 symbols, we only have 5 symbols, 0, 1, 2, 3, and 4. All right, and let's say we want to play the same game where we want to write out all of the numbers we can create. Well, let's start at 0, and let's go down, and we would get to 4, but now we've run out of symbols. How do we get 5? Well, we don't have the actual symbol for 5, right? Because we only have 0, 1, 2, 3, and 4. But surely we would want to create a number that has the same value as 5 in base 10. And so we do something very similar to what we do in base 10. When we run out of symbols in this column, we just add a different column and restart. All right. So now the number 10 in base 5 is equal to the symbol 5 in base 10, which is something I always found confusing as a kid. How does 10, so this is base 10, all of my base 10 numbers are going to be in red, this is base 10, and all the base 5 numbers are going to be in green. How does 5 in base 10 equal to 10 in base 5? It doesn't really make sense to me. And so it took me a while to really grasp what was going on behind the numbers and how we think of numbers in this way. So if we continue on with our base 5 listing of all the numbers, we would cycle through the ones column to get 4, 1, 4, and then just like we did with the base 10, we would just increment the second column by 1 and restart the first column back at 0. And we keep going until we run out of symbols, which in base 5 case would be the number 4, 4. All right. And just like in the base 10, if we run out of symbols in both columns, well, we'll just add another column and start each column back at 0. And this is how we create numbers in base 5. And so what you can think of is this column represents the number of 1s. That doesn't change from base 10. But this column now represents the number of 5s. And so what does this column represent? Well, this column represents the number after 4, 4. But what is 4, 4 in base 10? Well, it would be, so 4, 4 in base 5 would equal, let's see, it would equal 4 1s in base 10, but then it would also equal 4 5s, which in base 10 is equal to 20. And so 4, 4 in base 5 would actually equal 24 in base 10. And so 1 more than 24 in base 10 is 25. That means this column here represents the 25s column. And it makes sense because in base 10, each column represents another power of the base, right? So you've got 10 in the second column, that's 10 to the first, but then you also have this 100s column, which is 10 squared. Well, over here we have 5, but then we also have 5 squared. And so it makes sense. And so one question you might have is, can we convert from base 5 to base 10 or the other way around? And the answer is yes. All right, let's go from base 10 to base 5. Let's say we want to convert the number 121 in base 5. What is that equal to in base 121 in base 10. What is that equal to in base 5? And let's look at each column individually. In base 5, you have 1, 1, so that's 1, all right? In base 10, you have this 2 here, and 2 represents 20. And 20 is equal to 4 5s, right? So what we're going to do is put a 4 in for our second column, and a 0 in for our 1s column, because 40 in base 5 is equal to 20 in base 10, since there are 4 5s in 20. And now this last one, this 100, what's 100 in base 5? 100 in base 5 would be 4 25s, right? And so we would go to our 25s column and put a 4 there, and the rest are zeros. And now we can add everything up. This becomes 1, here's a 4, and here's a 4. So 121 in base 10 is equal to 441 in base 5. All right? Can we do the other way? Let's say I have the number 222 in base 5, and I want to know what is this equal to in base 10. Well, we can do something similar. What we have is 2 2s, that's equal to 2 in base 10. And now let's look at this 2. That means there are 2 5s, which is 10 in base 10, so we can write that in. And now this last 2 means that there are 2 25s, which is 50 in base 10. And so when we add all these up, we get the number 62. And so we can conclude that 222 in base 5 is really equal to 62 in base 10. And that's how we think about numbers in different bases. And this has always been a confusing topic to me since I first learned it in sixth grade. It really took me until college to figure out, oh, that's what we were talking about when we learned about base 5. So I hope this helped. I know this is a very confusing topic, um, and I hope it gave you a new way of thinking about how we create numbers. All right. So look out for the next video for more base 5 problems.